Hello, I'm Kevin Keach. Having understanding of the requirements of the DDR3 system, I'll give an overview of how that required information can be entered into the layout application to ensure that a rooted and constraint compliant DDR3 system can be physically realized. We will now constrain the design to ensure the topology, impedance balancing and skew requirements of the DDR3 system can be met. Note the design only contains the DDR3 circuitry. First, we will create the topology templates in relation to the requirements of the DDR3 system. As we examine the topology template for the address, control and command signals, it should be noted that there is a VBP where each SDRAM pin is connected to the main routing path. The other two VBPs are required for impedance balanced routing. These two VBPs are named Start Lead-In and Start Neck Down and are positioned at the start and end of the widened routing section. We will check the topology definitions for the differential clock signal, the differential strobe signal and the data signals. The differential clock topology template has VBPs in similar positions to the address, control and command topology. The differential data strobe signals are point-to-point and require only a simple topology definition as shown. The data signals are also point-to-point. We have now created topology templates for all the DDR3 signals. Many constraints can be set directly on these templates. This makes applying constraints to designs much faster and reliable. Minimum and maximum length constraints are set on pin pairs within the address, control and command topology template. Pin pairs can include VBPs as well as component pins. Route widths can be controlled at pin pair level. These widths are also set within topology templates. For differential topologies, differential pair spacing can also be controlled at the pin pair level. We can now easily assign the topology templates and their associated constraints to the DDR3 signals in our design. The physical view of an address signal with the topology template assigned shows the path as defined from the controller at the top right to the evenly spaced memory devices, including the associated VBPs. Similar results are observed for the clock signal once the topology template is assigned. Skew constraints are set on groups of pin pairs called skew groups. For example, address, control and command pin pairs are constrained relative to clock pin pairs. Others are defined in a way. DDR3 application notes define minimum spacing constraints between different types of signals. These are set by defining minimum spacings between pairs of spacing classes, for example, clock and data. All constraints are now set, so we can now complete the physical design. An address signal is routed to follow the signal topology. Here it is to be routed from controller to the memory devices and onto the termination devices.